So I'm going backwards a little bit, going into my write-up a little bit, and we're going to talk about the counting principle that we've been using to count when in the group of objects that we're trying to count, there's objects that are duplicate. And the way that we were using the counting principle, making dashes, putting numbers in the dashes, and multiplying them, it works fine when every object is distinct. It doesn't work so well when there's duplicate objects. In fact, it overcounts when there's duplicate objects. Let me try to explain this by using an example. So, how many ways are there to order the letters A, and B? I do better writing capital letters than small letters. So how many ways are there to order those three letters? If we use the counting principle, it probably would be just, you might think, well, for the first letter, there's three letters to choose from. I can choose that A, or that B. Doesn't matter which I pick for the first letter. There's only going to be two to choose from for the second letter. Doesn't matter what I pick for the first two letters. There's going to be one to choose from the third. And you might say that there's 6 ways to order the letters A, and B. I claim that this counting principle doesn't work when there's duplicate objects. And in here, the duplicate objects are the duplicate A's. I claim it overcounts when there's duplicate objects. And real specifically, I can show you that that answer of 6 is incorrect by just trying to list all the ways that are possible to take 2 A's and a B. The problem is that I can't tell these A's apart. So let me show you the ways that these are possible. I could list this as A first, A second, and B third. That's one of the ways. For the second, I can say it's maybe A first, B second, and A third. So essentially B can be third, B can be second. Or it could be B first, A second, and A third. So the B can be third, second, or first. The B has to be either first, second, or third. It can't be anything but first, second, and third. And once the B is placed, there's only one choice for the A's. The A's only can go in the other remaining spots. So really, how many ways are there to order the letters A, and B? The answer is 3. There's only 3 ways that are distinguishable, because if I switch these 2 A's, say this was a red A and that was a green A, this right here, when you're saying that there's 6 different arrangements, you're saying that I could tell the A's apart. But if you can't distinguish one A from another, then included in this 6 would be kind of switching a red A and a green A. And I'm not saying that the A's are different. So because there's duplicate objects, in this case the duplicate A's, the counting principle overcounts. And that's really unfortunate, because now it gets crazy and I have to pull out a formula, and the formula has nasty symbols in it that we haven't got to yet. So how am I going to answer the question to how many ways are there to arrange the letters A, and B? The answer is 3. When there's duplicate objects, there's going to be a formula to figure out how many ways there are to arrange the items. And the formula looks like this. It's going to be n factorial, which we haven't talked about factorial yet, over n sub 1 factorial times n sub 2 factorial. That's a mess. And it goes ... The formula says take the number of objects factorial, which I'll have to talk about in a second, divided by the number of times an object repeats factorial for each object that repeats. For this particular problem, the number of objects, or the number of elements, are going to be 3. So I'm going to do a 3 factorial for the number of objects, in this case 3 factorial. And then in the denominator, for any object that repeats, I'm going to put the number of times it repeats. In this case, there's one object that repeats, it's the A. and it repeats 2 times. So I'm going to say this is 3 factorial over 2 factorial. Factorial means to multiply, starting with that number, going down by 1, all the integers that are less than it till you get to 1. 3 factorial is 3 times 2 times 1, and 2 factorial is just 2 times 1. So we start with a number and we increment down until we get to 1. So this is going to be 3 factorial, which is 3 times 2 times 1, which is 6, over 2 factorial, which is 2 times 1, which is 2. These are the 3 ways that you could arrange the letters A, and B. Again, the 3 ways are having B third, B second, or B first. So in this particular problem, for the counting principle, if we're asked to count the number of ways there are to arrange objects when there's duplicate objects, we have to use this formula. And let me do a more complicated problem where there's more letters, or more letters in this case, and more repetition. So let me pull out another example, skip over some of the stuff that I typed up because I don't think it's going to help you to read everything that I wrote up. It'll just help us to get some problems done. So, in how many ways can the letters in the word Tallahassee, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, the letters Tallahassee, there are 11 letters in Tallahassee. Sorry. How many ways are there to arrange the letters? Well, because Tallahassee has duplicate letters, I can't just make 11 spots and say there's 11 letters to choose from for the first letter, 10 for the second, 9 for the third. That's because there's duplicates. There's 3 A's, there are 2 L's, there are 2 S's, and there are 2 E's. The formula that I started to show but maybe didn't show so great tells me if I'm trying to rearrange from a group of objects where there's duplicate objects, I can't just make as many dashes and increment down by 1. I have to use the formula. And the formula tells me to do this. Form a fraction, and in the numerator of the fraction, write the number of objects that you're switching around. In this case, I'm switching around the 11 letters. And I'm going to do an 11 factorial for the number of objects I'm switching around. And then in the denominator, for every letter that repeats, I need a factorial for it. So I need a 3 factorial for the 3 A's, a 2 factorial for the 2 L's, a 2 factorial for the 2 S's, and a 2 factorial for the 2 E's. Yuck. Well, 3 factorial is 3 times 2 times 1, and each of the 2 factorials is 2 times 1. So I can probably clean up this denominator quite a bit. So this is going to be 11 factorial over 3 times 2 times 1 times 2 times 1 times 2 times 1 times 2 times 1 times 2 times 1. This is going to be 11 factorial. Let me get this denominator down. So the denominator is 3 times 2 times 1 times 2 times 1 times 2 times 1 times 2 times 1. The denominator is 48. You can do 11 factorial by going 11 times 10 times 9 times 8, but that's a horrible, horrible thing to have to do. My calculator actually can do factorials. Let me show you how to get this numerator on my calculator. So to get the 11 factorial that I need, I type the number 11, I go over and I hit the math key, and then I'm going to use the left and right arrow. Starting with math, I arrow over once to num, once to CPX, and then once to PRB. And then once you're at the PRB screen, you can see the exclamation point for the factorial. And so that's going to give me 11 factorial, which is 3,939,916,800. This is what I want to divide. I want to take 39,916,800, which is the numerator, and divide it by the denominator, which is 48. My answer to this is going to be 831,000 There's 831,600 ways to arrange the letters of the word Tallahassee. If I wanted to, I could have done this all on my calculator if I used parentheses for the denominator. So let me show you a slicker way to enter this on your calculator to get this 831,000. So I'm going to do the numerator, which is 11 factorial of the unsimplified version. So math, PRB, down to 4 and hit enter. And then divide it by parentheses, 3 math, PRB factorial times 2 math, PRB factorial times 2 math, PRB factorial times 2 math, PRB factorial. I should get that same number. So this is the same computation, the numerator divided by the denominator, and I didn't do any work in my head on the denominator. Put the denominator in a parentheses and you get that same exact number. If you don't put the denominator in a parentheses, you probably won't get the right answer. Let's do another example, and then we just have a few homework problems to deal with. So in how many ways can the letters in the word starburst be arranged? So how do I do this? Simple. Because there's duplicates in the letters, I can't just make 9 slots because there's 9 letters in the word. So I'm going to start off doing some counting. The word has 9 letters. I'd like to use the counting principle and make 9 dashes, but I can't because there's duplicate letters. Let me figure out what the duplicate letters are. There's 2 T's. There are 2 S's. There are 2 R's. And that's the only repetition I see. So how many ways can the word starburst be arranged? It's going to be 9 factorial in the numerator for the 9 letters, divided by 2 factorial for the 2 T's, 2 factorial for the 2 S's, and 2 factorial for the 2 R's. So on my calculator, if I wanted to do this, just to get practice, I'd go 9 math, arrow backwards for PRB, then down to number 4, and then divided by parentheses, 2 math factorial times 2 math factorial times 2 math factorial, close out the parentheses, and I get 45,360 ways to arrange the letters in the word starburst that are going to look different, taking into consideration there's duplicate letters. So we just have 3 homework problems to do, and we'll be done with this section. So let's work on problem 25 together. I won't do 26. So how many ways can the word Mississippi be arranged for these letters? So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. If I did that right, 4, 7, yeah. So there's 11 letters. Let me go for the duplication. There's 1 M, but there's 1, 2, 3, 4 I's, and 1, 2, 3, 4 S's, and 2 P's. So how many ways can the letters of the word Mississippi be arranged? It's going to be 11 factorial divided by 4 factorial for the 4 I's times 4 factorial for the 4 S's times 2 factorial for the 2 P's. My answer key says there are 34,650 ways that this can be done. Let me make sure my calculator can do that, or I can do that on my calculator. So on my calculator, I'm going to go 11 math PRB factorial divided by parentheses 4 math PRB factorial times 4 math PRB factorial times 2 math PRB factorial. Close my parentheses. Hopefully I see 34,650. Perfect, I do. I'll let you give 27 a go. I'll do 28. On 28, I want to arrange these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. So there's 10 letters, but there's doubles. There's going to be 3 B's, 3 C's, and 2 D's. How many ways can these be arranged so I could tell them apart? It's going to be 10 factorial for the 10 letters, divided by 3 factorial times 3 factorial times 2 factorial. For your 27, if you want shooting for an answer, I got 12,600 for yours. I'll do this on my calculator just in case you need to see the calculator work again. Hopefully you can see that. So 10 factorial divided by parentheses 3 factorial times 3 factorial times 2 factorial, close my parentheses. My answer is going to be 50,400. So one more problem each. I'll let you pause the video. You can try to do problem 29. If you get the answer right, then you don't have to watch me do it, but I'm going to do it for you. So I got 415,800 ways to arrange the letters in Abracadabra. How did I do that? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. That's going to give me an 11 factorial. And then there's 1, 2, 3, 4, 5 A's. That's going to give me a 5 factorial in the denominator. There are 2 B's. That's going to give me a 2 factorial in the denominator. And there's 2 R's. And that's going to give me another 2 factorial in the denominator. So I think that computation, 11 factorial over 5 factorial, 1, 2, 3, times 2 factorial times 2 factorial should give me the answer. And I wrote 4 factorial. I'm worried about this answer not being right. On my little key here that I've been cheating, I have a 4 factorial for the number of A's. So apparently I couldn't count 1, 2, 3, 4, 5 A's. So that answer could be wrong. So let me do this. 11 math PRB factorial divided by 5 times 2 times 2 factorial, parentheses, 5 math PRB factorial times 2 math PRB factorial times 2 math PRB factorial. Haha. I guess I only get 83,160 ways. So that answer was actually wrong. Sorry about that mistake. That is the last problem I have for us to do. So I'll just stop the video here, and then we'll just move on to section 4.7. We're so close to the end.